In this video, we will add a CameraFollow script to our game. We are going to make sure that when the client picks up an object, it appears in its hand on both screens, so for every client. And we are going to also make sure that we can drop an object when we pick up something else. Let's start with a CameraFollow script that will make sure that the camera of a specific client follows its own player object. Let's go to our _scripts folder, right click, create a new C# script. Let's call it CameraFollow. We have already faced this challenge when implementing our interaction detector script that detects the objects only on the object that is owned by this client and doesn't run on other player prefabs that are spawned for other clients. So one of the solutions that we can use here is assuming that we add this CameraFollow script onto the player prefab game object, we can inherit from the network behavior and use ifOwnerCheck to ensure that this script only runs on the object owned by this client. We are going to add three fields: private camera m_camera, the vector3 m_offset from player, and vector3 m_origin position. We could use Cinemachine camera package as well, but let's keep this simple so that we can move faster through this tutorial. When a client joins, it always spawns at the position 000, so now we make the camera always follow and keep the offset from the player to the camera position so that it always follows the player the same way. Now if we disconnect, you will see that the camera has moved back to the position where when we spawn again, we are going to again have the same view on the player. It's a bit naive solution, but that's all we need for our simple project. Now let's override, and we are going to override on network spawn method. It's best to always do things in a multiplayer session in the on network spawn first, unless you are sure that you can use another lifecycle method from mono behavior or network behavior. So first of all, we need to check if is owner, and we need to check if this is false. In this case, we are going to return. Next, we are going to get the camera reference m_camera equals camera.main, assuming that the camera in our game has a main tag on it. And next, we can assign the m_origin position equals m_camera transform position to save it so that we can restore it if the client disconnects. And we are going to assign m_offset from player equals transform.position, so the position of the player object that belongs to this client minus m_camera transform position. So this is how we are going to keep the same offset from the player to the camera and just move the camera with the player. Let's override the on network despawn method because we need to always check if is owner, and we are going to check if m_camera is not null. And in this case, we are going to just assign m_camera transform position equals the origin position to move it back to the origin position before we disconnect. We could add an extra if camera equals null check here, but for now, let's implement the late update method because here is where we want to implement all the CameraFollow logic. And what we are going to check is if is owner again, so that we only run this logic on the owner of this script, and m_camera is not null. And if this is the case, we are going to assign m_camera.transform.position equals transform.position, so the player's position minus the offset so that we keep the camera at the same distance from the player. So again, I want to point your attention to that we are using isOwner often and onNetwork spawn often in those scripts connected to a multiplayer session, and this is the main difference between implementing scripts for multiplayer and for a single player game. Okay, save the script, let's go back to Unity. In our project, let's find a network prefabs folder, let's select our player and let's add to it CameraFollow script, and we can test it by pressing play. Let's try starting a host, and we can see that the camera follows the host. Let's connect as a client in player 2, and we can see that the camera now follows on its screen the character owned by this player 2, and on the screen of the player 1, the camera follows correctly the player 1. If we disconnect using the player 2 disconnect button, the camera moves back, and if the player 2 connects again, the camera correctly follows it again. The next step is to finish the object pickup logic. Let's go back to our network prefabs folder and open our player prefab. Here we can see that it has this mannequin medium mesh object, child object. Holding Alt key, click on this arrow to expand all the child objects of it, and somewhere here you will see 4 disabled objects. If you enable them, you will see that the different object models are appearing in the hand of the character. That's because we are making a game. We will fake picking up objects by just enabling those objects assigned to the player's hand. Let's disable those objects because we are going to enable them through the script. In our pickable base script, we already have this kind of solution. We have stored the is available as a network variable bool flag, and when it changed, we have listened to onValueChanged method, and we have changed the availability by enabling and disabling them for each client automatically without having to send any RPCs. So that's a similar solution that we are going to apply on the in the player controller script. So let's select those 3 dots and edit the script. To be able to show you 2 different ways of enabling the objects by just disabling them and despawning them, we are going to need actually 2 network variables. So let's create a new private network variable, and we are going to pass here a ulong since we are going to save the network object ID. Let's call it m_held network object ID. And this will only be suitable for the tools that we hold, equals new, and we can assign the ulong.max value, assuming that there will never be an object with an ID equal to this value. We don't have to specify permissions because the default ones are everyone can read the value and only the server can assign it, so the server has authority over each network variable. We will store the ID because when we pick up an axe object, we are not going to actually remove it from the map and despawn it from our multiplayer session, so we will have to access it, and the easiest way to find it in a different version of our multiplayer scene is through the network object ID. To know what to do with other objects that were actually despawned, we are going to save them as a private network variable, and we are going to pass object type, which is our enum, and let's call it m_held object type equals new object none. So we assign the default value as a none. This will become useful later when we have our resources and we want to drop them off at the destination point so that we know what we are dropping by checking the object type. Now, this might be a bit confusing that despite the fact that our client owns the game object, the network variable is actually owned by the server. But actually this way, a client can never bypass the server validation and cheat by directly setting those values on their own and changing the object that they are holding. This is connected to the topic of authority and ownership. So the client owns the player object because it provides input for this object. But the server has authority over the game state, what the player is holding, what they can interact with, and whether an interaction is valid. Now, to be able to trigger or enable our objects that our player will be holding, we need to add 4 private game object fields, m_axe model, m_pickaxe model, and for the future we are going to add m_wood model and m_stone model, and those will be serialized fields so that we can assign them through the inspector. With that done, let's search for our onNetworkSpawn method, because here, if this is an owner, we want our client object to react to the object being swapped, the object that we are holding. So let's type m_held object type on value changed, and we are going to add to it a listener handle held item changed. This is because if we pick up an object, the let me get closer. The client's player object should be updated on the screen of player 2, player 1, and other clients connected to our session. So we do not want to change it for the owner alone. We want to change it for every instance of this object on every machine. Let's generate this method, and we can copy this line and search for our onNetworkDSpawn. And let's make sure that we assign our handler method from our onValueChanged event. We can click on the name of the new method and press F12 to go to it. And here we can see that we are taking previous value and the new value. So all we will do is access our m_ax model, pickaxe model, wood model, and stone model, and use setActive, so the default method to enable and disable objects on the machine of a client. And we are going to check if the new value, so the value that we are assigning, is equal to object type belonging to this tool. So for the axe model, we are going to check object type.axe. For the pickaxe model, we are going to compare it to object type.pickaxe. For the wood model, object type.wood. And for the stone, object type.stone. But here's the tricky part. When the player 0 has picked up an object and the player 2 disconnects and starts client again, the object disappears, but because it is not synchronized for the late joining clients, and this could be a source of bugs in our game. We did this because I wanted to point out the tricky part of working with network variables. Because they already have the newest value when the late joining client joins our session, the handle held item changed method will never be triggered for this client when it joins. We have to trigger this logic manually in the onNetworkSpawn method. So let's add a handle item onJoin method, and let's right click and generate this method. And here we can check if m_held object type.value is not equal to none. We are going to call the handle held item changed callback, passing the object type.none as the first value, the previous value, and m_held object type.value is the new value to trigger the enabling and disabling process of the game objects that are assigned to those variables. So that's a solution to synchronize your own custom network variables with the late joining clients. Okay, last thing that we need to do is find our RPC, which was the request pickup server RPC. Here we are going to assign our network variables because here we are picking up an object. So at the end of the if checks, we are going to add another one. If the pickable item is pickable tool, because only those are of interest to us when assigning the network object ID. So m_held network object ID dot value equals the network object ID passed to this RPC. This will be useful when we want to drop the object when we pick up something else. Now below those if checks, we are going to assign m_held object type dot value equals pickable item dot object type. As you might remember, the pickable base script implemented the public field object type and can be picked up a bool flag, and those were properties that we have implemented previously, and that's why we have implemented them so that we can access this data when we pick up an object. Let's test our changes. Let's save our script and go back to Unity. Before we can press play, we need to assign those models, so let's expand the mannequin mesh object again, and let's assign the axe model, the pickaxe model, the wood model, and the stone model. And when you're done, let's exit the prefab and we should be able to press play. Let's start a host in the game window of the editor and start a client in the player 2 window. And sometimes you might get this network config mismatch because probably the prefab was not saved, or alternatively we didn't save the scene. So let's stop it. Make sure that you save the scene, or you can also restart the player 2 in the multiplayer play mode. so that it all gets synchronized. I have entered play mode again, and let's start a host, start a client, and we should be able to walk towards the tools now. And let's see if we pick up an object. It should appear in both windows so that the player 0 has the axe. If I disconnect and start client again, the player 0 still is holding an axe, and we can move to pick up the pickaxe. And there is our last issue, that the axe is now gone. It is still disabled. To implement that logic, we need to go back to our player controller script. Let's again find our request pickup server RPC, because here, when we pick up a new object, we want to make sure that we drop the object that we are already holding. The dropping logic needs to go before the assignment of a new value as the object ID. If m_held object type.value is different than the object.none, we are going to call drop current item method. And we can right click on it and generate the method. We can press F12 to find it. And here, first thing is to check if server is false. We are going to return because only the server can move the tool, because the tools are owned by the server. Next, we are going to check if m_held object type.value, and we are going to check if this is equal to object.none. And if this is the case, we are going to want to reset the m_held network object ID.value equals ulong.max. Again, we assume that no network object will have an ID equal to this value. In this case, we just return. Last thing to check is if our m_held object type dot value is object type dot axe or object type dot pickaxe. This is a C# expression is pattern with OR. GitHub Copilot has already generated this code for me. So this first if statement checks if our network manager, which we can access because we are inheriting from network behavior, .spawnManager.spawned objects has the object with the ID that we have saved. So try get value. We are passing the m_held network object ID network variable .value, and we are outputting the network object target. Now here it made a mistake because we are checking if target has a component, so try get component out, not pickable base. We are interested in a pickable tool script because it has the drop method. So if it has this component on it, we are going to save the reference as a pickable item, and we can call pickable item.drop, passing the position of our player object so that we can spawn there our tool. After this if statement, we need to make sure that we have dropped the object, so we are assigning m_held object type equals object type.none, and we need to assign the value here. I always forget about that. And we need to assign m_held network object ID.value. We're going to assign it as ulong.max value. And this is how we reset our data on this component. We should have all the additional code that we need for this to work, but there will be one problem. What happens when the player disconnects? Well, on the screen of player 0, the pickaxe should be dropped again on the ground, and when the player connects again, the pickaxe should be at this new position. And right now we didn't implement it in our code. So this is another tricky part of working with multiplayer. We need to think about those issues as well. So what happens when we disconnect? What happens when someone connects late? And for this, to handle the problem of disconnecting, we need to go to our on-network despawn method. And if we are an owner of this game object, we are going to call request drop server RPC. We need to have another RPC because the tools always belong to the server, and we are calling it from the client. So let's right-click, generate this method, and we need to add here an attribute RPC send to server. And here we are going to call our drop current item method, and as you recall, we have added here check if isServer because this method could be called from anywhere. That's why we always need to add isServer check to a method that is not an RPC, because the RPC attribute always ensures that this method can be only called on the server object. Now we are finally done. Let's save the script, let's go back to Unity and press play. If everything went well, we should be able to start a server and start a client. And now, if we walk towards a tool, we are going to be able to pick it up. And if we pick up another tool, let me move the client here, the axe was dropped and the client 1 can pick it up. And indeed we can. And now, if we disconnect here, we should see that the tool has been spawned here, where the player was previously, and we can still detect it and pick it up, and we can now connect as a client, and now the axe is lying on the ground while the player 0 has a pickaxe in his hand, so everything seems to be working fine. In the next video, we are going to make sure that the client can interact with resource nodes using our tool, and at some point we are going to also implement resources and a sound to be played on the client side using a client RPC. See you in the next video.